So hello everyone, my name is Artem Boiko. I'm a miner who switched to data mining. I am founder of data-driven construction and OpenConstructionERP, or develop solutions for the construction industry. I consult large companies, software and construction companies on topic on AI, disruptive technologies and interoperability issues, and I'd like to share some of insights about data what I have collected over the past 10 years. So the goal of construction is to build something for the client. And since client and investor cannot do everything themselves, they hire us to manage the project, materials, standards, and costs. As a result, many people become involved in the project and make decisions. And today, most of decisions in construction are still based on personal opinion and experience. As a result, the construction process often becomes a zoo of disconnected companies and people communicating through opinions instead of data. And instead of using analytics and automated data, the client deals with the opinions of many experts, which are difficult to verify. But the client does not need subjective opinions. The industry is moving toward uberization, where project time, cost, and resources are calculated from data, not from assumptions, guesses, or personal opinions. And to achieve uberization, all we need to do is learn to quickly calculate the cost of resources and the project time. What customers want most is transparency, clear processes, and clear decisions. And today, there are many different sources of information between the investor and the project, and we try to connect them through processes. And in reality, we not deal with two databases. It's about hundreds of databases and software that somehow need to work together. And while databases can technically be connected, the real problem is that every system uses different formats, structures, and data types. And one possible solution is to place AI agents in every database to structure and connect the data with our systems. Technically, this is possible, but does this really make sense? Technology alone does not create value. Real value comes from rethinking the whole system. The same happened 100 years ago with electricity. In many cases, the companies that first started using electricity later lost to companies that completely redesigned their processes around it. And the same will happen with AI. It's not enough to simply add AI agents everywhere. We need to completely rethink processes and data management. Most likely, the first companies that place today AI agents in every process lost to companies that completely redesign how data in processes are structured and managed. And the problem is not only that the data is different. In many cases, we cannot even connect the systems because the applications and databases speak different languages. And one of the biggest obstacles to data sharing in the construction industry is the fragmented databases and closed data structures used by CAD and BIM systems. I started researching the history of CAD, BIM, and BIM more than 10 years ago, and since then I have collected many insights and facts about how software vendors and large companies manage and control data. So one of the first people to think about full-scale project management through data was Charles Eastman, often called as father of BIM. And he proposed that construction projects should be managed through structured databases where drawings and geometry play a less important role. And in his white paper in 1975, you will not find the word BIM, but you find the word database 43 times, because the main idea was database-driven project management. And in 2000, Autodesk itself released a similar document. Even before Revit was acquired, we published a white paper, Integrated Design for Manufacturing. And where the main idea is to say that users and developers do not need neutral formats such as STEP or EFC format at all. Autodesk explains that neutral formats like EFC do not provide the required quality, and that both developers and users need direct access to a CAD database. And 2 years later, in 2002, and shortly after the acquisition of Revit, Autodesk published its BIM white paper. This paper was also mainly focused on integrated databases. And in this BIM white paper, from Autodesk, databases are mentioned 23 times. The key thing we need to understand about this story is that almost all large companies have been working directly with CAD databases for the past 30 years. Software vendors do not really work through BIM or EFC alone. In practice, we rely heavily on reverse engineering. And if we work the same way as large companies, when instead of relying on proprietary Revit or complex EFC format, we can work with direct access to all project information through database. In this case, we only need to transfer the required parts of a CAD database into our systems, such as SkyFrame, 4D, 5D, or ERP. And to create new data set from transfer, we need to quickly group and filter it. And a common example is creating quantity takeoff. And if you use always different and BIM, open BIM programs, you have the same output, same result, but the effort is very different. And for example, to obtain quantity takeoff with ETH OpenShell, you need to write 100 code lines. To create quantity takeoff with Python in Revit, you need 40 lines of code. And if you need interface, you need 70 different buttons to achieve the same result. But if you use dataframe, you have access to database, you only need one code line to create same output, same quantity takeoff table. The difference is what semi-structured data and BIM data, we first need to navigate through complex specification for EFC or CAD systems to find the required elements. With structured data, the process is much simpler. We do not need to search for prepared data, we only need to filter it. As my example, I started to collect different projects at about 20,000 different Revit and EFC projects in one table, and today it's hundreds of people build workflows and pipelines. On top of it, you can scan QR code. And once the data is structured, you can interact with project database using popular libraries, like in Kaggle or in Python or SQL. To group and analyze data, you don't need dozens of interface buttons or large BIM software tools. When working with database or data frames, creating quantity takeoff table, it's only one code line. It's same for graphs and dashboards. You only need one code line to create p-chart or bar chart from data. And this means what between your CAD data and maybe, for example, a PDF report with a quantity takeoff table, you need only 20 code lines in Python. So, but in reality, it's not simple for us to work directly with CAD databases because users usually do not have access to them. But at the same time, all large companies and almost all CAD vendors already use technologies that give them direct access to CAD data. They just do not speak about it. And here on this slide, you see is founding member of such organization. It's where guys pay about between $50,000 until $300,000 per year for be here as founding member. It's Microsoft, NVIDIA, all CAD vendors without exception, and we have access to CAD databases, yeah? And for example, Trimble use ODA software development kit to import data from Revit to SketchUp. It's same for Graphisoft and Nemetschek. We use data from Revit in Archicad thanks to ODA SDK. And Bentley and Hexagon, it's same. And Autodesk itself used ODA since 2018. And no one here needs EFC or Open BIM for interoperability. So because users don't have direct access to CAD databases, concepts such as BIM, Open BIM, EFC, and buildingSMART were introduced and promoted in the construction industry. And for the last 20 years, these concepts have been driven and marketed by CAD vendors. And if you work seriously with data, if you need 4D and 5D phases or calculations, you eventually force you to retune to closed BIM solutions. If you're interested in the detailed story behind BIM, Open BIM, you can watch my 20-minute video on YouTube. So what you need to remember, any file, any project or CAD data can be transformed into structured data. Once the data is structured, you no longer need complex buttons or interfaces to work with it. And once you gain access to structured data, the real challenge begins. Connecting this data to real processes and workflows, to real use cases. As Autodesk CEO Carol Batz in 2005 said, for every engineer who creates something, we have 10 our people who must manage, process, and work with this data. So with open and structured data, we no longer need closed formats, complex APIs, or plugins on applications. Instead, we can work directly with data through open source tools, open standards, and open libraries. In this way, we made a full transition from BIM back to CAD databases, and finally to open structured databases that can be connected and used across different systems and workflows. So now all we need to do is build pipelines between our structured data tables, which are used in different use cases. And the final question is which tools we will use to create automated pipelines for our processes. The answer is simple: open source workflow tools, AI agents, Python libraries, and low-code automation platforms. By 2024, it became possible to simply import structured table from Revit into ChatGPT or Claude and generate quantity takeoff using a simple human request. At the bottom of the slide, you can see a prompt. At the top, you see as result generated from Revit. So it's same for EFC or AutoCAD data. Using free open source tools, we can generate dashboards, reports using just a few simple prompts written in plain language. So in 2025, the next major step happened. LLMs charts were no longer limited to simple database queries. Instead, they became capable on building, automating pipelines and workflows. You can simply describe your idea in chat in Cloud or ChatGPT, and the system generates a ready-use pipeline. It's like a JSON, which you copy-paste in your environment. And the same pipeline can be reused across thousands of our projects. So we now have open data, and we also have free low-code tools that allow us to describe and automate almost any business process with some prompt in LLM chat. So I have some of my own pipelines, which you can find on GitHub repositories. For example, we include batch conversation of different CAD formats into structured databases, or full automation of project verification workflows, which can be reused across any numbers of projects, independent on project format. Or you can also create complete automated pipelines with verification, classification, reporting, and calculation project cost and time, and carbon footprint emissions. And once such a pipeline is created, it can be reused across any number of projects, formats, and software versions. And by 2026, we are no longer limited to querying project databases or creating automated pipelines. With AI agents, we can now build complete platforms and applications for our business processes. So in 2026, when you work with open data, you no longer need hundreds of buttons and disconnected interfaces for transferring information between systems. Instead, you work directly with databases through free and open source solutions. For 40 years, working with tables and databases required special interfaces and hundreds of buttons. But over past 3 years, everything changed. Today, we have AI and vector databases. Now you can simply talk to your data the same way you talk to our person. We have already made a quantum jump back from BIM to structured databases, and the next quantum leap will be transition to vector databases. So if we are working with small tables, we don't need to use vectorization. Small data, simple queries. But there is a problem. We need to process thousands of tables, and we simply cannot check the quality of them quickly. And strict verification rules make it difficult to find the right group or type for calculation. And vectorization helps us speed up the mapping process using the classification we need. So to avoid the problems of strict queries, we will look at project differently. We will look at it same way as LLM, like ChatGPT looks at a book. So here's my example, a table with 50,000 unique construction work and jobs described by resources. It has about 1 million rows and about hundreds columns. I had to learn how to find elements using simple words, the way builders and clients speak, and using this QR you can find out how it works. Now I get a complete estimate just by describing the construction project or group elements in text. And with or without vector databases, pipelines are changing the way construction data is processed. This is no longer a traditional workflow where an employer starts work at 8 a.m., opens the program, and manually export tables, import tables. Instead, the process becomes a fully automated ETL process, extract, transform, load, where pipeline was run overnight. So now all data is available to us and can be automatically organized in the workflows we need. And ready-made digital products are now being created at the same speed what Ford Motor Company once used to produce cars on the assembly line. So in the end, you need a legacy system in which the user could create the use case he needs from open source blocks. So at the end, data level, this is a simple tables that connected to 4D, 5D calculations or to obtain dashboards. And the OpenConstructionERP project, you can already see almost everything discussed in this presentation: open data, automated pipelines, AI workflows, quantity takeoffs, generation, and database-driven project management. So in the next few years, it will be extremely interesting and complex. We will have open data, we will have many open source solutions and many AI agents, and of course, estimating project cost and duration will no longer belong only to construction companies. With open data and AI tools, this calculation will become accessible to everyone. And construction companies will not be able to make money from speculation anymore. New times are coming, and in this new paradigm, the customer will have a new, more important role. So a year ago, a second edition of my book was published for free. It contains many facts, examples, what is discussed today. Thank you for your attention. Thank you for having me.